Hello everyone, my name is Taketo Inoue from the University of Tokyo. I'd like to talk about image recognition applied to a robotic platform for mass dissection. Firstly, I'll talk about background of our work. We target mass dissection in the orbit. The significance of this task is to study the effect of microgravity on astronauts' body in their long-term space missions, for example, muscle atrophy, bone density loss, and so on. Understanding these problems will also apply to the study of human aging because similar health problems are found in the elderly on Earth. Now, at the International Space Station, to obtain samples, rodents are dissected and preserved by astronauts, and the samples are analyzed after their return to Earth. To reduce their burden, our group is developing a robotic platform for mass dissection. The most significant challenge of teleoperation in the orbit is large communication delay, which is known to approach 6 seconds. Therefore, it is essential to automate some of the dissection tasks to overcome the problem. This slide shows the telerobotic platform that our group is developing. To avoid the operational errors due to large communication delays, progress of the task in the space side need to be automatically monitored. Now the robot is under development and no data has been collected. So we use the manual mass dissection videos as the dataset in this study. This figure shows flow of mass dissection. In this study, we focus abdominal incision task. Research objective is to automatically detect the incision area in the abdominal incision task by image processing. The incision area means the area already open during the incision task, the yellow part of this image. Detecting incision area enables to monitor the progress of incision task and to stop autonomous incision when the incision area is not increasing. There is a challenge that the incision area may be partially or fully occluded by operator's hand or surgical instruments, like this image. This slide shows the overflow of the proposed method. As I mentioned in the previous slide, the incision area may be partially or fully occluded. The proposed method is performed in 2 steps. First, semantic segmentation is performed. As shown in this figure, we annotate the images into 5 classes: incision area, yellow, forceps, red, scissors green, skin blue, and background black. In this step, all pixels in an image are estimated to be one of the classes. In the second step, incision area classification step, the incision area is estimated from the segmentation result of current frame and previous frame. We evaluate our method, and this table shows training condition in semantic segmentation. We use the intersection over union score to measure segmentation quality. And this table shows semantic segmentation result. Mean IOU of all classes score is 0.915, and IOU of incision area is 0.949. This score shows each area could be identified effectively, but the recognition rates of surgical instruments, forceps, and scissors were lower than those for the other classes. And this slide shows incision area classification result. The estimated incision area is the number of pixels estimated as the incision area. The estimated, the blue line shows the area estimated as the incision area in semantic segmentation, and red line shows the area estimated as the incision area after the incision area classification process. The estimated incision area was greatly reduced when the incision area is occluded by operators' hands or surgical instruments. But our proposed method was able to reduce these effects. So the proposed method is better to monitor the progress of incision task. To sum up, we propose a method to estimate the incision area during abdominal incision task. The incision area was monitored even with the image occlusion by the operator's hands or surgical instruments. In the future, we will improve the segmentation accuracy by implementing the robotic kinematic information, which will be collected during rodent experiments by the robot. And we will autonomously control the robotic system using the progress monitoring by the proposed processing method. Thank you for your attention.